The press is controlled by a Dard Logix processor. We have the standard processor and the safety partner. All of those are communicating with the chassis. The first card in the chassis is an Ethernet communication card. That's connected to the Ethernet switch as well as a remote access modem. All of the other items in the cabinet communicate over Ethernet. The next item in the rack is a AMCI high-speed counter, or PLS module. PLS module controls all of the high-speed outputs in the control. The next one is a resolver module that is used for the redundant resolver on the main shaft. The next card we have is an analog input card. The analog input card is connected to the tonnage TTLM module. There's strain gauges on each of the 4 channels that all feed back into this module here. The next cards in the chassis are 4 high-speed counter cards. Those are connected to the ram adjust and all of the press adjustments. Ethernet also runs down to 3 of the 4 safety modules. The safety modules have the palm buttons, e-stop, and guards all wired to those. They're all redundant inputs. There's also some additional safety relays for the clutch and brake control. And also we have just the fuses and starters for this side of the cabinet. In this side of the cabinet we have the 3 digital input modules and 2 digital output modules. They're connected to the standard I/O modules on this side of the enclosure. We also have the high-speed output modules. Those are connected to the AMCI PLS module. These run the Platen exhaust, core rod, all the other items that need to be updated quickly. We also have the feeder servo control. It's controlled over Ethernet also. There's no programming in the module. It is all contained in the processor. And it's a single wire connection out to the ball screw feeder. The feeder has a absolute position encoder on it. We also have a main power supply for 24 volts, another one for the counters for the platens and press positions, and a surge suppressor. Up at the top of the cabinet is the main drive controller, the PowerFlex 755. It also has all of its parameters controlled over Ethernet. The press is controlled by an Allen Bradley ControlLogix processor that's connected to the PanelView Plus 1500 touchscreen control. This is where all the parameters for the machine are entered. It also displays all of the fault information for the machine. The main run screen contains the press position of the machine as well as the feeder position. It also has displays for the main shaft RPM, strokes per minute, and parts per hour, and also displays the tonnage on this main screen also. This press also has encoders on each of the adjustments. Their positions are read out on the screen also here. The center of the screen allows you to log in as supervisor and set up to be able to change the parameters on those screens. We also have counters for shift counter, lock counter, and a batch counter that counts down. If you can program this setting for 1,000 strokes, and it will run for 1,000 strokes and then shut the machine off. Also at the bottom of the screen, we have all the other push buttons that take you to all the other setup screens, and also a rolling fault banner at the bottom of the screen that shows you all of the currently active faults. There's also a continuous mode enabled indicator that if you hit the continuous button, it shows you that you have 5 seconds to start the machine. The first one of the screens we're going to look at is the selector switch screen. If you hit it, it shows all of your selector switches for the Platen exhaust, core rod, underfill, all of your cycle delay, cycle stop are all located on this one screen. To change any of them, you just touch the button for that particular parameter and touch whatever one you want. The next screen is the program function screen. All of these settings are modified from this screen. When you move the key switch into program, it lets you, the green boxes show up and you're able to touch the screen and type in the new parameter you want. It also shows you the limits on each of the screens. The second screen is for some additional inputs, spare outputs, and auxiliary faults. The feeder setup screen shows all the setup parameters for the feeder. Each of the positions has its own adjustable position and speed. There's also switches to turn the functions off and on the right-hand side. The next screen is the machine settings screen. This screen allows you to enter your air pressures for all of the adjustments. This is basically just a scratch pad where you're able to, once you have the job set up, you can look what all your pressures are and type them in there to record them for the job. Second screen shows all of the positions for the encoder readouts. Next screen is the save and recall screen. This allows you to save all of the settings from the program functions. the feeder setup and the machine settings to a program. You're able to then change the name of the program to whatever you want it to be. We also have compare programs that shows you if there's any differences between the program that's currently running in the machine and the way the program was whenever it was last saved. The press utilization screen allows you to keep track of the time that the machine was running, and when it's not running, you're able to tell it, record why the machine was not running, whether it was for setup or for a break or for maintenance. The part check setup allows you to add a sensor to the front of the machine that checks the part as it comes out of the press. Automation screen is a custom screen for the part picker system on the press. It allows you to enter all the settings for when the picker goes in and out and when it opens and closes. There's also some additional checks for the part being not stuck to the upper punch and things like that. The tonnage setup records the tonnage from each of the 4 columns, as well as the overall tonnage for pressing and for ejection. There's also process limits on this screen where you can program them for the minimum and maximum of your part. There's also a load detect setup screen on the screen that allows you to set up the early load detect system and the no load detect system to shut the press down if you have load too early or not early enough on the press. The way it works is you would, again, get a good part running, get the machine running, and what the system looks at is it determines when the machine's actually seeing load. This one is set at 5 tons, so whenever the strain gauges see 5 tons of load, it knows that's when I'm starting to press on the machine. So what you would do is you would capture that position by pushing this button, and in this particular screen, it was 151.6 degrees is when it saw load the last stroke. So what it would do is between 10 degrees and 149.6, you can see there's a 2-degree offset there. That's programmable also. If we saw 5 tons or more on the machine between 10 degrees and 149.6, it would shut the machine down. Same way on the opposite side, there's also a no load detect, and again, it's got a programmable window. This one's set at 3 degrees. That if between 154.6 and 170, if it doesn't see 5 tons, it will shut you down also. If you don't have any powder in the die or whatever, maybe keep you from clinking your tools together. So that's how that system works. So you get it up and running, figure out where it's seeing 5 tons, and then you capture that position. Everything else is based off of that. The main drive control screen allows you to set the speed of the press. It also gives you an indication of how fast it will run if the cycle delays are turned on. The maintenance screen shows the position of the wedge checks and the fill checks. Also has other buttons that allow you to go to the press monitor. Press monitor keeps track of all the valves and how many times they fired and lets you set a resettable counter to alert the operator if one of these valves needs maintenance. The I/O monitor screen shows you the status of all the inputs and outputs on the screen or on the machine. Shows you the standard I/O and also the safety I/O. Feeder diagnostics is a maintenance page that shows you all the parameters associated with the feeder as well as a torque feedback from the feeder down here at the bottom, and it'll bounce back and forth and show you how much torque it's taken to move the feeder. It's a very powerful servo motor and ball screw on there. Sometimes it's really hard to tell how much force it's actually taken to move it, but you can see on the screen here that if you're pegging out your torque one way or the other, you have an issue with it. And that would be the same way if we did put servo adjustments on there. That's kind of where this came from, is from the servo adjustment, because you really have no feel as how hard it's taken to turn those. But with the torque, you can see that it's always 30 or 40%, and all of a sudden it's pegging out. You know to stop, and there's something going on with it. All of the torques are still limited, and we can limit them whatever percent we want, but it still gives you a good feedback on what you're seeing. If you're logged in as supervisor, there will be a supervisor maintenance button that appears. This takes you to the supervisor maintenance screen. From the supervisor maintenance screen, you can set the main shaft position of the machine. You can also set the time and date on the processor. There's also some buttons that program custom features in the top right-hand corner, as well as the load detect setup. The Trabon grease setup screen allows you to set the grease system on the press. Right now it's set to stroke every 500 strokes, and it has to complete that cycle in 120 seconds. Adjustment setup screen allows you to reset the position of all the encoder positions on the press. These can be set to any position you want. It also gives you an indication of how to measure to set these setup screens. The overload history shows all the overloads on the machine, what time and date, and pressing and ejection tonnage when the fault occurred. The fault screen shows all the currently active faults and also gives you access to the fault history screen. The fault history screen displays all the last faults on the machine. It records up to 2,000 faults, gives you the time, date, the name of the fault, and the total machine strokes when that fault occurred.